In this series of videos, I will try to code quicksort algorithm. Well, for the theory part, I just wrote quicksort here, and I have checked out these two videos, this one and this one. Uh, this video is really nice. This video is really nice. This is not my video, of course, and I learned a few things, a few terms, and you're going to use the term wall and pivot. I really like that part, so I'm going to use these terms from this video. And for the theory part, I think it's my personal choice, but this video I think is better. For the theory part, it's a little bit better. So the theory part, I'm going to be referring from this video. Actually, I'm going to be taking the elements, these elements from this video. I have the same elements written here. So I've done this program before. Actually, I don't do this often. I usually code it um, on the fly, but this time I thought I would come prepared. So I've made this quicksort file before, so I'm going to making another file and to code this in front of you. Quicksort 2.c. First the basics. Actually, just copy paste these things. Is include stdio, then con.io, then the array elements up to this, and let me just copy and paste here because it's pretty decent. I mean, come on, everyone knows how to do this part. So I want to use a function, and the name of the function is going to be display. So void, and these videos are going to be capped to 10 minutes. So these videos are going to be max 10 minutes long, and yeah, that's it. So let's do it. So int I, for I is equal to I is equal to 0, I is less than len I plus plus. Then let's print out the value. So printf printf, yeah, printf printf, then %d space, then ar of I. Just let me just add a numeric character here. It will be helpful later. Here's two numeric characters. Okay, let's copy this thing and the end also. So display function is ready. Now let's add the main function. So int main, and this is code block, so there's no void main is in main, and int main returns 0. Now let's print the array first. Let's just see if the display function is working out. So display void, let's just run it once. Yeah, it's working. So this is our original array, and now we have to code the quicksort function. So void qsort, there are going to be two parameters actually, left and right, int l and right. Okay, what is this left and right? Well, we are going to be working on this array. Left means the left index, right means the right index. I suggest you go through this video first. The theory is discussed there, and it's pretty nice. Just open this for a minute. It's something like this by web tuning. So I think you can find this video. It ranks pretty high. So then if you have gone through this video, you will note that after one pass of the algorithm, the last element, that's 7, that's a pivot element, this would find its actual position, its actual true position in the array. Means where would 7 belong in the final sorted array. It would find its position there. Suppose 7 belongs here in this position, then we have to call this function on this part of the array and on this part of the array. It means that the left subarray, the elements in the left subarray, the elements are less than the pivot element, and the right subarray, the elements are more than the pivot element. The theory is here, you can see it here. I'm not discussing the theory, I'm just working on the implementation. So now think, when would this function work? It would only work. Okay, when we need to sort an algorithm, when we need to sort an array, we need to sort an array if there are more than one elements. If there is only one element, that means it's already sorted. So if L is greater than or equal to R, that means it's already sorted. Then we don't need to do anything, just to return. This would just end this function. Nothing would happen. So now we need some variables. Int pivot is equal to R, while is equal to L, then I, then for I is equal to wall, I is less than pivot. We will be traversing. Suppose this is our array which we get here from L and R. Suppose L is 0 and R is 7, then we will be traversing from 11 up to 4, not 7. So we have to traverse up to R minus 1, that's pivot minus 1. So I less than pivot, I plus plus. Now what we have to check is if AR of I is, what did it do? Let's have better. I did was if AR of I is less than, yeah, if AR of I is less than AR of pivot, then what would happen? Then we would try to swap them. If AR of I is less than AR of pivot, if AR of I means this element is traversing from here, if it is less than pivot, then we would swap. What we would swap? We would not swap this with this. We would swap this with the wall element. Suppose the initially the wall is here. If this we would suppose this less than, okay, let's do an actual example, 7. Then what's less than this thing here? 2 is less than 7, so we will swap 2 with 11 because 11 is the wall element. Here 11 is the wall element. Pivot I'm sorry, wall equal to L is the left, so this is wall. Here we will swap 2 with the wall element, so this element which is smaller than the pivot, you swap that element with the wall element and then increase the wall by 1 index. So then in another variable actually comma temp, so temp equal to AR of wall is equal to AR of I is equal to temp. Okay, then we have to increase the index of wall by 1 position. After this is done, after this loop is done, we have to swap the wallet element with the pivot. This means that all the elements to the left of the wall is lesser than the pivot and all elements to the right of the wall is more than the pivot. So we swap the wallet element with the pivot element. So temp equal to AR wall, okay, AR wall equal to AR pivot, and a pivot, yeah, and AR pivot is equal to temp. Okay, so this is done. Then you call this quicksort function on left comma y minus 1 and quicksort on wall to R. We would call the quicksort function on the left subarray. We would call the quicksort function on the left subarray and quicksort function on the right subarray. Like the assumption here is all the elements to the left of the pivot is sorted is less than the pivot, and all the elements to the right of the pivot are more than the pivot. So we would try to sort the elements which are less than the pivot, and we try to sort the elements which are more than the pivot. So this is all for this video. I'm going to finish this the next video. I guess it's pretty easy. I'm running out of time, so see you guys in the next video.